Hello students. Today we are in chapter 2 looking at model building and gains from trade. As promised, we'll talk more about trade creates value. I set that up a bit at the end of chapter 1 and now we'll go in greater depth. However, before we get into that, we'll take a detour through looking at how economic models work. We'll look at the link between models and data. We will distinguish between positive and normative, and also endogenous and exogenous. So once we know how economic models work, we'll then make an application to trade, and we'll start with a very simple model. And we'll see how trade creates value. So I found this quote about economic models. It comes from Alfred Marshall, who was an economist back in I think it was the early 1900s. So here's what he had to say. Experiences in controversies such as these brings out the impossibility of learning anything from facts till they are examined and interpreted by reason, and teaches that the most reckless and treacherous of all theorists is he who professes to let facts and figures speak for themselves, who keeps in the background the part he has played, perhaps unconsciously, in selecting and grouping them, and in suggesting the argument post hoc ergo propter hoc. That was a long sentence. Marshall, unfortunately, like many economists, is not always easy to understand. Let's try to figure out what he is talking about here. So, though he was writing back in the 1900s, the earlier mid-1900s, the same thing he's arguing against is just as relevant today. You might hear things like, we're in the era of big data now. So you might hear sentiment like, we don't actually need these theoretical models anymore with all their assumptions. We can just rely on the data, just rely on the facts. We don't need models anymore. So that's what Marshall's referring to. He says, he who professes to let facts and figures speak for themselves, those who say we don't need theoretical models. And Marshall cautions against this. He says actually he calls those people the most reckless and treacherous of all theorists. So what is so bad about relying upon just data alone and not using models? Well, he says that you need a model in order to interpret the data. In order to make sense of what's going on, you need a model to tell that story. That's what he's referring to when he said the impossibility of learning anything from facts till they are examined and interpreted by reason. He also cautions that if you try to go without models, you are vulnerable to some logical fallacies. So first of all, you could end up cherry-picking the data. I'm going to talk a lot about this one fact that I really like, and I'm not going to talk at all about the facts that undercut my narrative. That's what he refers to when he talked about keeping the background the part he has played, perhaps unconsciously, in selecting and grouping facts and figures. So he's saying over here, perhaps unconsciously, it might not be like the speaker is trying to inject their bias into this, but they might still end up misrepresenting things anyways because they're picking some facts to talk about and others to not talk about. That can give you a misleading impression. So if you don't have a model, you're vulnerable to that. The other part of his warning is that there's a logical fallacy called post hoc ergo propter hoc. It means, if you translate from Latin, after this, therefore, because of this. So, just to make a simple example, let's say two things happen. A happens first, then B happens. Does that mean that A caused B? No, it doesn't. B might have happened for some entirely different reason. So just because A happened first does not prove that A caused B. Now, if you were to make that claim, A must have caused B because A happened first, that claim is a fallacy, and that fallacy is called the post hoc ergo propter hoc fallacy. If you don't have a model, if you're just looking at the data, you see events happen in the data, you see this happen in the data, you see that happen in the data. It's tempting to claim that the one that happened first must have caused the second one. That claim is not necessarily true. So you want to watch out for that logical fallacy. Models help you avoid that. That's why you need models. So, in short, Marshall is saying that models help you make sense of the data. They also help avoid cherry picking the data. And lastly, they also help you avoid post hoc ergo propter hoc. So, hopefully I impressed you with the fact that we need models. You can't go without them. So, some examples. We had the Great Depression back in the 1930s. I wonder if we'll call the coronavirus recession a depression or not. We'll have to see. So we had a Great Depression, and then we had a big economic recovery, which was preceded by a large increase in government spending. Did that spending cause the recovery? It might have. I would not assume so, based solely upon that they happened in sequence. So there are other things that might have caused the recovery as well. We had World War II going on. There are many other policies beyond increases in spending, high savings rate, and other things. So if you're going to take some more advanced classes in a field called econometrics, it's basically stats applied to economics, you can do a better job of sorting out what's really causing what, and then you can get a more definitive answer on this question. Simply saying because recovery followed the stimulus spending does not prove by itself that the stimulus spending caused recovery. You got to make that argument more carefully. I'm not saying you can't make that case, but you got to do it in a different way. So, if I add to Marshall's list of why you need economic models, it's because, unlike the hard sciences, in economics we usually don't have a controlled laboratory environment. So, in the hard sciences, if you want to know how one thing affects something else, you set up a laboratory to control every possible other cause and change just one thing at a time. That's how you know that any result you've seen must have been caused by that one change. Nothing else changed, so there's no other explanation. Usually you can't do that in economics. So we have to watch for events that happen in the real world, and then we have to go and compare our model's predictions with those events and see if our model did a good job or not. So I was saying, I'm not denying that the stimulus spending and the depression caused recovery, just saying that if you want to make that argument, you got to do it more carefully. So here's what you would have to know. So we got to know what happens after you increase government spending. We've got that already from the data. We also have to know what would have happened if everything else had been the same, but we had not had that increase in government spending. It's like you're imagining some parallel universe out there where everything was the same, but we did not have that stimulus. So the data can tell us what happens for number one. We did have an increase in government spending in the real world, and we did have recovery. But we don't know this, what would have happened. We need a model to fill in number two. So maybe we would have gotten a big recovery anyways, even if there had been no spending increase. That would have meant the spending did nothing. Or maybe we would have gotten no recovery. The Great Depression would have been much worse without the spending, so the spending did cause recovery. We need a model to help us tell number two. So this number two here is what would have happened. That's called the counterfactual. So models are all about trying to figure out that what would have happened, those counterfactuals. Now, there's a very important phrase here you'll hear quite a bit. That is ceteris paribus. That means all else the same or all else equal. So an otherwise identical universe that had no increase in government spending. So We need models to answer those questions. So one thing about economics that I think makes it very interesting is that it's not just about hard facts, it's also about our values. So we do have to be clear though, when am I talking about objective data and when am I talking about my opinion? So to make that distinction clear, we separate positive statements from normative statements. So by a positive statement, I mean one that can be tested and proven either true or false. So that's one's about the facts, this one's not about opinions. What's about opinions are called normative statements. So opinions, by their very nature, are not testable. So the way I avoid mixing them up, normative contains the root norm. So I think of things like social norms, like how we think people ought to behave, and that's a matter of opinion. So that must be the opinion one. If normative is the opinion one, the other one, positive, must be the fact one. So a quick illustration. The unemployment rate is 5.3%. It's a positive statement. I must have written this quite a while ago. It's way higher than that now in the coronavirus recession or coronavirus depression, whatever they'll call it eventually. So you can test and prove it true or false. In this case, I'm speaking on August 2020. It's definitely false. If I say instead the unemployment rate is unacceptably high, that's a matter of opinion. What's acceptable, in my opinion, and what's unacceptable is very much normative. So here I'll give you some examples. Go ahead and pause the video here and decide for each statement, is it a positive statement or is it a normative statement? So go ahead and pause here and think about that. When you're ready, press play and we'll talk about it. Alright, I'll assume you've given us some thought. So for our first statement, the minimum wage should be raised since poor workers deserve to have a decent standard of living. That one is normative. So what people deserve to have is a matter of opinion, what's considered a decent standard of living and what's not a decent standard of living, all very much opinion based, so this one has normative written all over it. This other claim down here is raising the minimum wage will increase unemployment, especially for workers without college degrees. That is a testable claim, so that can be proven true or false. You got to do some analysis to figure out if that's true or not, but it's testable, so that's positive. Statement number 3, economic growth in the U.S. has been below average since 2007. We can compute the average growth rate, and then we can compute the growth rate for after 2007 and see which one's bigger. That one is testable, so yes, that is positive. Our last statement, economic growth in the U.S. since 2007 has been too slow. Well, what rate is slow enough and what rate is fast enough is all a matter of opinion, so that would be considered a normative statement. So there are your answers. You have first and fourth are normative, and the middle two are positive. So I put a quick tip down here. A word like should or ought or to is almost always signaling this is an opinion. So if you see a word like that, it's very likely it's going to be normative. Alright, so now we know the difference between positive and normative. Now let's talk about endogenous and exogenous. Those words might look kind of scary, but the basic idea is actually not terribly hard. So there's a wide variety of economic models out there. However, they tend to share the same general structure. So the model is going to be a system of equations. You'll have a bunch of math going on. And the higher up you go in economics, the more math you'll probably see. So some variables will be inputs you're going to plug into those equations. Once you have that in place, you'll do some math and you'll get some solutions, and those will be the outputs. So I'm staying very abstract here because I want to say things in a way that's going to encompass all economic models and not leave anything out. So all we're really doing here is we're going to relabel those inputs as exogenous. The outputs are relabeled as endogenous. So importantly, we're not trying to explain the inputs. Inputs are exogenous. We're just going to take those numbers as they are. We're going to plug them in. The things we are trying to explain, we are trying to make predictions about and tell a story about, those are the outputs. Those are the endogenous variables. So all I really did here by diagram is I replaced input with exogenous, and then I replaced output with endogenous. Oh, another important tip. Here's how I can avoid mixing them up. So, a very long time ago that a lot of bugs have what's called an exoskeleton. Their skeleton is actually outside their body. That's very different from us. We humans have a skeleton that's inside our body. So if the skeleton is outside the body, we call it an exoskeleton. So exo must mean outside. Those are the outputs. So the other one, endo, must be the inputs. So you keep that story in your head, you won't reverse endogenous and exogenous. Speaking of not reversing endogenous and exogenous, I think your book's explanation is rather confusing. I have taught this in the past, and the book's explanation caused a lot of students to go astray. So I think your book is pretty good overall. Let's be clear about that. But in this particular topic, I think they could use some improvement. So for this part of the book, just focus on the technique we'll go over here and ignore that section on endogenous and exogenous from the textbook. So here's how I think about it. I'll tell a story in a couple of different ways, and then we'll go with the way it sounds more logical. So here's what I mean by that. We'll get a typical consumer choice problem. So consumer has some money in their wallet, and they have the goods price. You see the price sticker, and we can't negotiate that. So typical, like going to the grocery store or something. And you got to figure out how much stuff do you want to buy at that price. And we economists are trying to model what this buyer is thinking. So we'll think about what are the endogenous and what are the exogenous variables in this model. So I said I'll tell you a couple different stories and I'll pick the more logical one. So here's story number one. I observe the quantity that's available, Q. Based on that, I decide on the price, P, I'm willing to pay. That's our first story. Withhold judgment until you hear the second story, and then you'll tell me, well, I can't hear you, but you'll figure out which story is the more logical one. So in story number one, we saw Q, and then we decide on what we're willing to pay. In story number two, I look at the price they're charging me, look at P. Based on that, I decide on what quantity I'm willing to buy. That's our second story. So you look at the Q available and then decide what you're willing to pay, or you look at the price and decide on quantity. It's the second one. You get the price tag and you figure out how much you're willing to buy. So in other words, price is an input into my decision about quantity. So you plug in price into my brain, and then my brain tells me how much I should buy. So price is the input, so price is what we call exogenous. The outcome of this decision is the quantity I buy, Q, and outputs are endogenous, so Q is going to be endogenous. We have one last variable in our story. The consumer has W dollars to spend. So what's that going to do? Well, I also base my decision off how much money I have, right? So based on how much money I have and what the price is, I figure out how much I'm going to buy. Q. So W and P are inputs, W and P are exogenous, and Q is going to be endogenous. So that's our answer. Let's go through another example. So maybe some agricultural economist is trying to find out what the relationship is between the weather and agricultural production. So what are the endogenous and exogenous variables in this model? So same technique. I'll tell you two stories. You'll figure out which one sounds more reasonable. The more reasonable story is going to tell us which variables are which. All right, story number one. Because we had a lot of agricultural production, that's going to cause us to have good weather. Story number two, we had really good weather, and that caused us to have a high amount of production. Which one sounds more logical to you? So you probably said the second story, weather causes production, not the other way around. That's right. So if we go to our general model, weather is the input, has its effect on production. So weather is the input, so weather must be exogenous. Production is going to be the outcome of that, so that's an output. Agricultural production is endogenous. So that's how you figure it out. Again, your book causes a lot of students to be led astray, so don't follow your book's approach. Instead, just tell a couple different stories and stick with the more logical one. That will lead you to the right answer much more reliably. Alright, that wraps up the first part of this chapter. So be sure to tune in for our next episode, and we'll start applying our building blocks and models to looking at gains from trade.